digital humanities experience feels similarly for humanists and engineers, but I think this experience can be related to more to different effects depending on the side that you are. So I think that for the humanists, it feels more like a hype cycle, right? So this experience is moved or is driven by technological optimism, which is very very usual to find in these times, right? So as it happens with any technology hype, it starts with an innovation trigger, which in this case, and specifically with visualization research, which is something that we employ a lot in our work. It starts with this innovation trigger. So, for example, it could be the work by Franco Moretti with graphs, maps, and trees. Then everybody gets inflated expectations about about what it can be done with this technology, and then we all progressively realize that maybe digital humanities are not what we were expecting, and in the end we can go through some sort of slope of enlightenment that would ultimately take us to a plateau of productivity, right? So I think that also moved by this technological optimism from the engineering side. I'm an engineer, I feel more like this. Also as an individual experience and also as a collective experience. So in this case, I think it is more related to the Dunning-Kruger effect, which is a cognitive bias in which people wrongly overestimate their knowledge or ability in a specific area. So it is very common that, well, in my case, for example, when I started working in digital humanities projects some time ago, I was very confident that the technology that I was going to offer to the humanists will resolve many of their problems, but in the end, it happens that that's seldom the case, right? And we have to. It requires a great amount of effort to actually design visual tools and algorithmic tools that are able to resolve the humanist problems. So from our perspective, I will be decomposing what the title of this project means, which might sound unfamiliar to you. So we want to support decision-making in digital humanities research. So when we talk about decision-making, we are mainly talking about uncertainty management and representation. So we want to show this uncertainty and see how it affects the decision humanists make during a given research process in a given context. So this will be aided by data visualization and visual analytics tools. And for this, we'll employ a technique that we'll explain in a moment, that is called progressive visual analytics, that refers to opening the black box of the algorithm. So you might have used in the past algorithms that you don't probably didn't really know how they worked, and these techniques helps you to understand the inner workings of these computational resources that are at play in many digital humanities projects. Okay, so the consortium or the partners that we are involved in this project come from the University of Salamanca, which I belong to, specifically to the Visual Analytics and Information Visualization group at this university. We also have experts from the Austrian Academy of Sciences and the Trinity College in Dublin. And finally, we have colleagues at Poznan Supercomputer and the Networking Center in Poland. Okay, so, okay, sorry. I got that slide wrong. Sorry about that. Okay, so I think that this is the key text. I don't know if you know Johanna Drucker. She's been working in digital humanities for a long time, and she has a very popular paper that's called Humanities Approaches to Graphical Display. And here she comments on certain aspects of the graphical tools, and I think that it can be expanded to cover also almost every computational tool that is used in digital humanities research. And I think it's very interesting to go through what she says in this text to understand what are some of the current challenges in digital humanities and visualization for the digital humanities. So she says, as digital visualization becomes more ubiquitous, humanists have adopted many applications such as GIS mapping, graphs, and charts for the statistical display that were developed in other disciplines. So this is something that you will probably see, you have probably seen in many times, like importing methodologies from other research areas, probably the experimental sciences, into digital humanities that you get to use and producing probably or hopefully good results. But in relation to this, he says that such graphical tools are a kind of intellectual Trojan horse, a vehicle through which assumptions about what constitutes information swarm with potent force. Okay, so not very promising for us. But we will get to it in a moment. I'll see what's our stance to solve this problem. She continues saying, creating bar charts with ambiguity and degrees of uncertainty or other variables in them might cause champions of legibility and transparency some unease. But the shift away from standard metrics to metrics that express interpretation is an essential move for humanists and or constructivists across disciplines. So here we took this specific sentence as a proof that conveying uncertainty in digital humanities research is much needed, and there's a current need for visual support or analytical tools that support the traditional humanities research process. So this is one of the main motivations of this project. Okay, so here we also took some conclusions at the end of the a study made by Stefan Janicke and his colleagues, in which in 2015 they listed certain challenges in close and distant reading, referring specifically to spatial uncertainty, temporal uncertainty, so and also about producing novel techniques for close reading that you will see that we are experimenting with as well. And also the creation of legit usability studies that are able to measure the wellness and the fitness of the approaches when applied to the digital humanities context. Okay, so visualization for the digital humanities has lately seen a rise in their use. So there's a higher interest by the visualization community in experimenting with data that comes from the humanities research lines or research topics. So visualization, visual analytics can be explained as the transformation of the symbolic into the geometric, finding the artificial memory that best supports our natural means of perception, or probably the use of computer-generated interactive visual representation of data to amplify cognition. So there is clearly data visualization and visual analytics refers to the overload and correct manipulation of the human visual channel to augment the user's analytical capabilities. So it's basically the ability to convert data tables into graphical representations that help us understand what's in the data and draw conclusions in a faster manner. Here I'll be discussing a little bit what is the status of visualization for the current status of visualization for the digital humanities. So visualization for the digital humanities, it's a type of interdisciplinary visualization research in which domain and visualization experts collaborate together to study traditional humanities questions. So in this setup, the domain experts, the humanists, provide data and the driving problems and tasks. And here the visualization experts, in this case it would be me and Roberto and Alejandro, provide algorithms and visualization and analysis techniques that help them solve these problems. And it also presents some common elements with other interdisciplinary collaborations that are seen in visualization research, such as biological data visualization or visualization of computer security. But they also have many other features that make it quite unique. So as I was saying, visualization for the digital humanities has gained traction and popularity among visualization researchers. So recently, just last week, the 5th edition of the CHIST-ERA workshop was celebrated. This is a collocated event to the IEEE's conference, which is the main visualization venue in the world. So we were there, and it was quite exciting and quite interesting to be there. Also, the digital humanities, it turns out that they are an exciting field of experimentation for visualization, because, well, as an engineer or as a visualization researcher, you are normally facing data sets that are rich, they are normally underexplored. So that means that they have been sitting in a library for many years, and they were just freshly digitized. And this is obviously very, very exciting to work with. And also there is a feature that make this field very, very exciting for us, because the digital humanities pursue different aims to those of other disciplines that are commonly supported or typically supported by visualization, like experimental sciences. So the digital humanities, normally they don't look for finding definite answers to the questions, but rather they try to find ways to make even better questions or more questions, right? So this is radically different from what you can see in other sciences and experimental sciences like biology or medicine or others. But we are trying to apply similar techniques that are proven to help in exploring data, and well, this is one of the main challenges. And this is why also they are very apt to test this novel visualization approaches. So this disparity in the aims of these research lines are it's often interesting, because, well, these evaluation techniques that were made for other sciences like experimental sciences are not fit, and also it means that previous visualization research is to get inspiration from is really scarce. So this is why sometimes we try to incorporate knowledge from other disciplines into digital humanities research. But obviously this needs to be properly evaluated if we want to match the aims of humanities research. Also, it turns out we've discovered in recent studies that the discipline right now is quite fragmented. So there is still a large conceptual gap between BIS48 and DH4BIS scholars. So this means that this refers to visualization scholars working on digital humanities and digital humanities scholars interested in visualization. So there is still a large knowledge gap between them, and these collaborations are usually difficult. Also, the humanists are used to publish their research in different venues and formats, and it also makes it difficult to make publications that are fit for both sides, for the humanities and the engineering side. So this is quite challenging too. And definitely there is a low overlap between these communities that with this project we are trying to shorten. So the question that we ask at the beginning of this project is that if there is a slope of, if we are facing a slope of enlightenment in digital humanities visualization according to the technology hype cycle and the Dunning-Kruger effect, are we going there or not? So we detected several research aims that we found that it would be interesting to address. So we wanted to design visualizations and interfaces that were able to capture the nuances of the humanities research workflow and make them well, less tool oriented and probably more task and need centered. So it's not about creating tools that can be used by everybody in a transparent manner, but rather we want to involve humanists into the design of these tools and orient them towards the solving of a specific humanities tasks. And also we wanted to create a specific software design and visualization design methodologies through different methodologies, through different processes like the user-centered design, participatory design, by involving larger and more diverse communities of probably also lay users. So we try to adopt citizen science methodologies here too. So this is the way we are going about this. Okay, so before I referred to visualization, so after we have talked a little bit about visualization and visualization for the digital humanities, I want to make a stop and comment a little bit on what progressive visualization is. Because we think it's a really hot topic in the digital humanities, and we think it also can address some of the issues raised by Johanna Drucker in her paper. So here, progressive visualization or progressive analytics is a novel visualization technique that refers to the idea of offering partial visual snapshots of the execution of an algorithm. So as you see at the top of the image, in a normal workflow, you select the data set, select the parameters, and run an algorithm, an analytic. So you have to wait for some time for it to complete, which may depend on the data, on the volume, data volumes that you are managing. And finally, when you get the results, you visualize them and interpret them. However, in a progressive visual analytics workflow, the user selects the data sets, selects the analytical parameters, and runs the analytics. But in this case, she doesn't have to wait for it to finish. Instead, she can get to see the partial results of this execution and start interpreting the output as the computational method is being executed. So this has many positive effects. The most obvious is probably being related to the visualization of large data sets, for which the algorithms may take a long time to complete. But also, it has positive implications in the way the users understand the computational methods they use, which is very important to break with this black box paradigm, which is sometimes very dangerous. And ultimately, more in relation to our projects, we hypothesize that progressive visual analytics are also a good fit for dealing with uncertainty representation, which, as I will show you in a moment, overcomplicates things a bit when it comes down to the graphical display of data. So here I show you an example of an execution of a minimum spanning tree algorithm. So this is Prim's algorithm. So basically tries to find shortest distances or a path that connects all points in the possible shortest distance. And here you can see how the algorithm executes. So imagine that at some point, what you are seeing, you don't like what you are seeing, and you are able to actually cancel the execution and change the parameters and rerun the algorithm again. So this has also, as you see, many implications in the way these algorithms are understood by the users, and also in the it affects the speed in which the conclusions can be drawn from the data. So this is something that we are trying to incorporate into our platform. So just to wrap up a little bit this part, the PROVIDEDH project aims to give digital humanities scholars a space to explore and assess the completeness and evolution of digital research objects, since they are digitized and they enter the platform, and also we aim to measure and to communicate how the participants or the stakeholders of a project interpret what they see and how they communicate what they think about the data to other users. Okay, so it's important that they share these perspectives and insights with other stakeholders, and enabling like a kind of a collective reasoning on the data objects, on the digital research objects. So, and as you will see, as you may imagine, this is an interdisciplinary research project, which means that the experience gained in other scientific areas in which the intervention of computing has been traditionally much deeper and constant is analyzed and transferred to the case of humanities research. All right. So basically, we want to address two key scientific questions that motivate our project. So is it possible to assess the degree of uncertainty that a particular digital humanities dataset incorporates, tracking such degree during the evolution of the dataset, and measure how it is affected when different computational models are applied to it? And is it possible to convey this evolution of uncertainty by means of interactive multimodal interfaces that progressively adapt to the moment in which they are used and permit to the users to make decisions accordingly? So we want to not only capture, quantify, and convey uncertainty, but also we want to measure how the interpretation of this uncertainty that comes with the data leads the users to make one decision or another within a digital humanities context. Okay, so what we are talking a lot about uncertainty, and well, what is uncertainty, right? So you may be wondering this question, or asking yourselves this question: what is uncertainty and how it applies to my own research? The thing is that uncertainty, from what we could learn, can mean many different things. So because it is subjective, so different people may agree on what uncertain or uncertainty is, but it depends on the context, on the cultural background of these persons, and in the situation, in the task. So the task they are performing, sorry. As you see, this opens up for many interpretation pathways of what uncertainty can mean. However, and just to give to frame the project in a specific context, when we talk about uncertainty visualization, we are referring to representing the range of values the data could be, as understood by other people or by an algorithm. And this means that we will be mainly talking about probabilities. As I pointed out before, it's all about calculating these probabilities, but also communicating these probabilities with, in this case, visualization techniques or appropriate visualization techniques, and understand how people grasp these probabilities, and finally identify how uncertainty communication and its assimilation by the users affects the decisions they make in this context, in a digital humanities context. So to illustrate this example, what I mean by visual uncertainty representation, here I took an example. It was created by Jessica Hallman and Matthew Kay from the Midwest Uncertainty Collective, which is a group of researchers in the United States, who have been developing approaches to visual uncertainty communication in recent years. And here the chart shows you unemployment over time between the years 2008 and 2019. And probably you've seen this chart lately with similar data, especially with the COVID crisis. You have probably seen this many times. And this data may be incoming from you have seen probably this data for other countries and with similar data, right? With trying to show trends and these kind of things. Obviously, when you look at these charts, you immediately draw different conclusions from it that depend on your background, on your experience, previous experience with the data, etc. So concretely, in this case, it is obvious that the unemployment in the United States was steadily decreasing since its peak in 2009 and 2010. But the curious and important thing to realize in this chart is that the points that composing this line are estimates. So nobody really thinks that exactly in April 2009, the 3.6% of the US population, which is roughly 11,700,000 people, were unemployed. So nobody thinks that exactly this number of people were unemployed at that time. But in the same way, nobody either thinks that this graph is misleading. However, if you give it a second thought, this graph, it is misleading a little bit. And why? The problem here is that obtaining the real value, right, knowing exactly how many people in the United States were unemployed at the time, it's nearly impossible. So there is no possible way we can go interview every single person in the United States every 3 months to know about their employment status. So how is this chart composed then? It was done, if you know a little bit about the statistics, it was done by sampling the United States population. So you go out and interview a few people chosen randomly, and from there you draw conclusions that are estimates in this case. So why, if the points in the line are estimates, they are shown as discrete values in the chart and not as ranges, right? So the reason that this is done in this way is that it can be traced to cultural aspects that relate to the public's general level of visual literacy, I think. So typically, uncertainty has been conveniently concealed from the viewer's eyes in the charts, just not to overcomplicate the charts too much. However, there are many problems, I believe, with this approach. The first one is that if we keep doing this forever, then the public will never know why representing uncertainty is important. Because after all, a graph that does not represent uncertainty is deceiving, as I was saying. So maybe this was unintended by the creators of the graph. But how do we distinguish between the charts that do it in purpose and those that that they are actually trying to to manipulate you as you read this chart. So this is a real danger for transparency or for creating a well-informed and critical society, which I think should be one of the main aims of sciences and specifically the humanities, I believe. If you look at the chart, you can see that here we could represent that point estimate in April 2019 with a probability distribution function. So what is a probability distribution function? A PDF is a graphical representation that tells you what the ranges of what are the ranges between the data could be, and what are the chances that the data could be between certain ranges, better said. So we here in the PDF that you are seeing there shows the chance that unemployment was between certain ranges. So for example, the statistical model that was used to compose the data, shown in the chart, indicates that there was a 90% chance that the unemployment was between 3.5 and 3.8. So it's very unlikely, but not impossible, that the unemployment was outside this range. And this is a very important thing to realize when looking at these charts, that heavily affects the way the data is understood. And as a consequence, the decisions people can make after inspecting this chart. Also, this takes us to identify one uncertainty category that I will be presenting later when I will be talking about uncertainty taxonomies. Generally, it's useful to make a clear distinction between estimations and predictions. So estimations relate to uncertainty in what some value is or was, which is called reducible uncertainty. It is reducible uncertainty because we could go out and ask every person in the United States to tell us about their unemployment status. And this would effectively reduce the probability to a single point. So we could, there's a possible way that we could create the chart that I showed you originally in the first slide. However, when we are making predictions, we could generate a model that predicts what unemployment would be, in this case, in May 2019. At the time these charts were created, it wasn't known. There is a key difference to realize also in this case, that in this case, no matter how many people we interviewed, we could never know what their unemployment status would be in May. So because it was impossible to predict what the future will be. So this is called irreducible uncertainty. So it cannot be reduced. So notice here how the shape of this bell has changed to express this effect, that we are much less certain about what a variable will be in the future than we were about what it was before or what it's at the moment. Okay, so this is also a key aspect we believe it's important to communicate to the users. So I pointed out several things related to, or several features related to uncertainty visualization, and I've pointed out how this uncertainty can be classified in typologies or taxonomies, whatever you want to call it. So we were more or less sure that we wanted to adopt one taxonomy that would work for digital humanities projects. And we try to employ existing uncertainty taxonomies that have been tested in the past in a humanities or social sciences context. Another factor that we considered to choose one taxonomy over the other, over another, was its inherent ability to be communicated by visual means. And as it turns out that the GI sciences are typically more related to these two lines of research. So we looked upon previous work by other authors to compose our own taxonomy that we have been progressively refining since the start of the project through different evaluations. So here you can see one of the main artifacts, that's a chart that depicts the taxonomy of sources of uncertainty for digital humanities that we could come up with. Specifically, it contains 2 dimensions. So you can see the x-axis captures some of the types identified by other authors that I mentioned in my previous slide. So here you can see at the top ignorance, which means that there is a lack of context and information that doesn't allow me to understand what I'm seeing. And this is different, for example, from non-credibility, which refers to an observed bias or error that I have become aware about. So this becomes more obvious when, for example, I observe misalignments between my prior beliefs and what I'm seeing in the data or in the results of an algorithm or in annotations made by another person. And in turn, this is completely different from variation, which is also known as imprecision, which refers to the idea of different values within a contested of the same category. And also, we added a 4th category. It's called caps, also known as incompleteness. So this is an outlier record where information is missing, which is very common also in digital humanities research objects. For now, we have been trying to, as I said, refine this uncertainty taxonomy. And we divided this taxonomy between the 2 types that I introduced before. So it would be the epistemic or reducible uncertainty, or aleatoric of irreducible uncertainty. So the first one, it's subjective and it's interpreted and it's induced into the system or into the data by humans. So for this, we chose a 5-point Likert scale. So users are able to express their lack of certainty into something that they are observing, and they can choose between any of these 4 categories. And also, we are considering to introduce machine-generated uncertainty, which refers more to the kind of uncertainty that cannot be reduced sometimes because the algorithms give the results in a manner that it doesn't make sense to be reduced, because many of these algorithms are probabilistic. So these results cannot be reduced, right? It's the way in which the algorithm itself was designed. So an important part of the PROVIDEDH project relates to evaluating these taxonomies. So for this, we had several workshops. We had one workshop celebrated with Digital Humanists at the Trinity College in Dublin, and in consisted of the analysis of the writer and novelist, and Irish writer and novelist Samuel Beckett. And the participants provided us feedback in a questionnaire. So we asked specifically about how the different taxonomy categories related to their own research, and how they related to the example we gave them. So we obtained generally very good results that I go and explain in a second. And also we had 2 workshops that they were oriented more towards working with lay users, and they were centered on the annotation of historical recipes, a corpus of historical recipes. And for this, we were still in the making of, or in the process of making the platform. So these annotations were made on paper and then translated into the platform, and then they were later analyzed. So referring to the first workshop related to that was celebrated, in Trinity College in Dublin, we had 8 participants with different backgrounds. You can see all them there. So we had PhD students in creative arts, in history, in digital humanities. In general, there was a quite varied set of persons, and we try to evaluate how relevant do they think this incorporation of uncertainty and the worsen in general was for their job. So we found that well, a majority of them thought it was a good idea to incorporate this kind of research or this kind of knowledge in their research, but they found that it was difficult for them sometimes to translate these categories into their own specific research contexts, and this is something that we are being trying to achieve. And this relates to, for example, also to the results that we obtained in the other workshops. That's when annotating recipes, people sometimes didn't know what category they should choose, and also we observed that some kinds of uncertainty were seen more often than others, but way more often, significantly more often than others. This, for example, referred to the inability of the participants to understand certain words, because this was historical texts. These were historical texts, and sometimes the language that it was used in the corpus couldn't be understood by the user. So we also try to evaluate how people reason about about the taxonomy or the categories that they were offered. So we conducted an analysis of the annotations that were made related to each one of the categories, and we could certainly observe an overlap between these categories. So you can see this in this heat map. So, for example, we just said that incompleteness and imprecision had a higher level of overlap than other categories. So this probably means that in the end, these categories shouldn't be crisp and well separated, but probably sometimes it's better to make the taxonomy flexible for them and allow them to compose the taxonomy as they go. So from these workshops, we could extract the conclusions and the hypothesis that uncertainty greatly depends on the task and the user's mental models in this case. Also, we observe that the users will always try to adhere to a given taxonomy. So if you give them 4 categories, they will use them, or they will try to use them, the 4 of them. But if you give them 5, they will try to use 5. So we realized that probably the key point was not invalidating a common taxonomy that works for everybody, but in assessing whether the user's internal uncertainty model is taxonomical. So people naturally organize the uncertainty as they see it into different categories. Also, it is important for us to know whether these categories or this categorization of uncertainty is interpersonal. So different users with similar profiles, for example, experts or lay users, working with the same data will spontaneously employ a similar internal uncertainty model, despite changes in the names they use to refer to the categories. So this is something that we have also incorporated into the platform. So now users are able to specify the number of categories they want to use, and they can also specify the name, so other people can see them and use them. And also, if they need more, they could probably add more. But this is also performed on a project basis. So this means that when the project is created, the person that owns the data, who owns the data, will create this taxonomy for other users to use it. Also, we finally found that the distribution of uncertainty categories will be probably biased towards certain types, and since the degree of the perceived uncertainty will greatly depend on the user's mental model, the chosen category, their expertise, and the specific task that they are performing. So it is important to realize that these different the categories or the choices that the users will make will depend greatly on the nature of the data and what the users are instructed to do with this data, or what they want to do with this data. So we are trying to adapt the system to cope with these things. So here you can see a snapshot of the project creation page. So here, for example, we are using the default taxonomy that we are offering at the project start, at the project creation. So we have 4 categories, but you can add more, and each of these categories is mapped to a color in a color scheme. So each one of these categories is associated with one color in a categorical scale. Okay, so going back to the annotating the TEI files in a collaborative manner, we detected the need for making a visual annotator. So our goal in this case was to allow collaboration between researchers in an uncertainty-aware context and in a transparent manner. So we didn't want users to access the actual TEI files, but rather we wanted them to use an annotator that supported uncertainty annotations in a multi-user environment. So here you can see a snapshot of the visual annotator that we'll showcase later. So here you can select the text and then give this annotation category, a specific uncertainty category, and a different value of confidence. Okay. So here I depict the idea in which this collective reasoning will work, and this sense making in a computer system environment will work. So for example, in this case, it could always start with a run of an algorithm who would make annotations according to a certain logic. And then in turn, this would be interpreted by a second user producing a certain interpretation that will be reflected in the document and saved into the system. Then a third person would come and see the results, which in turn would make him extract certain conclusions that will depend on all the previous ones, regardless of whether they were made by a machine or by a user. So you can see how this can quickly escalate into a complex network of annotations and assumptions that will affect the way the user interprets the data. So we want to actually measure and quantify what's going on in all the previous steps, and to offer the user the best possible interpretation in a given context. Okay. So okay, now I will be showing you the platform. For this, we have created a video that's I will be playing now. So it will take like 10 minutes to complete, I think, but it will give you a rough idea of what the platform consists of. So I'll see you when it's done. Okay, so that was it. Let me. Okay, so we are back. I hope you enjoyed the video and give you a nice or accurate idea of what it can be done with the platform. So you have been following it. Probably you've seen that we have centered some of the work in the annotation of and identification of entities in a corpus, but we are also actively supporting like free uncertainty annotations made by the users. So just to move to the last part of this workshop, I'll be presenting a use case that we have prepared for you to get your hands in the platform and to get an idea of how you can interact with the annotator and extract conclusions from by using the platform. So here we'll be using the 1641 depositions. The 1641 depositions corpus is composed by transcriptions of witness testimonies of the opponents. So they were mainly the Protestants, but also some Catholics from all social backgrounds concerning their experiences of the 1641 Irish rebellion. So the testimonies document the loss of goods, military activity, and the alleged crimes committed by the Irish insurgents, including assault, stripping, imprisonment, and murder. This body of material is unparalleled everywhere in the early modern Europe, and it provides a unique source of information for the causes and events surrounding the 1641 rebellion. So just to give you a rough idea of how the dataset is composed, it contains roughly 7,000 depositions in TI format, which in turn are composed by a header, which contains some metadata like creation date and place, the keywords, the nature of the deposition, the list of participants, responsible people for creating the document, and the data transcription, etc. And then we have the body that contains the actual digital transcription of the original text, and well, there are the original normalized digital transcription exist. So we have been mainly using the normalized transcriptions to current modern English. So here you can see a rough overview of the possibilities that this dataset corpus has to offer. So, for example, we see that here there are 35,000 distinct names detected in 6,000 files composing the dataset. That these were the files that could be used in the end. Here the time of the temporal resolution of the data set is the day, so therefore there are many possibilities to aggregate this data into months or years and decades. So we see that the majority of the positions in the data set occurred in 1642. However, a non-negligible amount, that would be roughly 5%, have records with null creation date. So it means that probably it can be known by inspecting or by exploring the dataset. And also regarding the space the dimension of the datasets, we can say that the resolution is the town village, so populated place. So the data has been aggregated into counties and displayed, for example, on PROVIDEDH maps, which is something that we have already experimented with. So the county Cork, to offer some numbers, holds the highest number of depositions, so around 1,000. But also, as it occurred with time, there is 5.5% of depositions for which their location is unknown, which also offers nice exploration paths, right? So okay, so to go to the use case, we have prepared a project that contains a set of 7 depositions, which describe the activities of a group or groups of approximately 200 rebel soldiers participating in the Irish rebellion that were active throughout Ireland. So a close reading of the selected depositions reveals that some are related, providing details of a cohort of rebels active in the Munster province in the south of Ireland. Of the remaining depositions, some might be connected, whilst others are clearly unconnected. So you will have to go and read these texts and annotate what you think about what you're seeing. So the aim of the exercise, as I'm saying, is to work through each of these depositions to determine whether these groups are or not related. So you may identify here in the process areas of uncertainty in the individual text. So for example, measurements of distance, such as a masked shot or half a masked shot from a particular location, or vague temporal references such as the middle of or a particular month or a saint's day, which you probably are not familiar with. So we would like to encourage you to annotate this and in the process of determining if these groups are related or not, and then we'll have a short discussion in which we will comment on how and why you annotated these kind of things and why you think they were important to support this decision-making process and this reasoning process. Okay, so now I will pass it over to my colleague Alejandro Rodriguez, who will be performing a live demo just to show you how to go to the platform and sign up. Then we will add you to the project, and you will be able to start annotating. So if you want, you can go to that URL. I will leave it here for a minute or so, and then I will pass it over to Alejandro to continue with the workshop. Okay, so thank you for listening, and I hope that you found that interesting.
So good afternoon, everyone. First of all, we are now going to make use of the online collaborative platform on which I will ask you to sign in. I will do so myself right now to show the registration process, and going through some of the things that we saw in the video, I will show too what the platform has to offer and how basic operations are done. So first I will access the platform, which URL you have in the chat. And there we have 2 options, which are logging in case you already have an account, or creating a new one, which I do right now. Clicking on the sign up button, and it is a very simple process, which just requires filling the formulary. So I will quickly fill it as you may do so yourself. And clicking on sign up will create the account. Once this is done, will be automatically logged in and presented with the project selection page. So working in the platform have the data organized in projects. These projects appear in the initial page and are comprised of a set of entities, uncertainty categories, and files, as we saw before. So the first time you enter here with no eligible projects, you have some extra information, such as the project description, the platform, sorry, links to TI documentation and a sample file. We already saw how projects could be created, changing the taxonomy, the entities that are used, and so on. But for this use case, we will not have to go through this process. You will be granted access to an already existing project once you are signing. So if you don't see the workshop project, just refresh the page, please. And
can you give us a thumbs up when you are logged in and can see the project, please?
And I will stop for a moment right now so that people can sign in for the project. Let me see if I can see the chat.
So Irena is saying that she cannot see the case study.
Sorry,
please.
I unmuted myself for as I understood, you are gonna I mean, give us permission to go to this case study, or?
Yeah. You should see it.
You don't see it, so.
Please refresh the page, the browser, if it does not show.
I see it now. I see it now. Thank you.
You're welcome. Okay, I believe there's still a few people to sign in. Maybe let's wait for a minute or so, and we'll continue.
If there is anyone left who don't have access to the project after refreshing the page, please write your username in the chat.
Okay, I think more or less everybody has already signed in.
Yeah.
And so you can, Alejandro, show them how the annotations are made.
Sure. So clicking on the workshop name, on the project name, you will be logged into the landing page. So 6 different pages are accessible within the project. Briefly, the project page with a list of the files, the 7 files that we already commented. a history of the analysis run in the project, and the recent activity. This will be updated as annotations are being created or the analysis is being run. We then have a dedicated files page with each of the files, which, as we already know, are in the TI format. A TI summary tool that shows how the markup is used within the corpus, so the different tags that are used to create the documents. As you would expect, this will be updated as we create annotations and we see how different entities are added to the project. We then have a dashboard app that will be showcased later on, the analysis tool that we saw, and a settings page that you may or not may have, depending on the privileges that you have. So a specific document can be opened by clicking on either the page within the landing page or in the dedicated files page. What we see is the raw document, the TI content, and we can click on close reading to open the annotator. The annotator shows the text content, entities, and uncertainty in a simplified manner. So it allows free text annotation by selecting text and choosing an option, modifying existing entities, and adding uncertainty to these entities. So let me show you how I would create and annotate a piece of text. I will first scan the text in search for something that catches my eye, like a name is Philip Rayfo Owen. I would choose whether to specify the entity type, add some uncertainty to the piece of text, or do both, create the entity and annotate the uncertainty. For now, we'll just select the entity type. So these entities that are available are the ones that you specify at project creation. And I will choose a person. As we saw, the name is Philip. So I will write that down and click on create. When you click on create, the message will be sent to the browser, to the server. It will process the request and will update the page for you. I've been having some internet connection issues, and maybe if you have them too, you may have to refresh the page in order to have the latest changes. Here we see the entity, which is shown as an underlined and with an icon piece of text. If we hover over entities, we will see the tooltip saying what the ID is and the attributes it has, and clicking on it will fix it so that we can click on the different things and interact with it. Now I am going to annotate the uncertainty for the data for the person that I created, clicking on annotation, and here we have three different options. One may have or may think something is uncertain regarding the spelling, the actual piece of text, the tag name, in case he or she thinks that it should be something else, or the attribute, some property value. Let's say that I have doubts regarding the spelling of the name, and I believe it is Philip, written like this. I would then proceed to say what the certainty level is. For me, it is low, and select the categories. You may hold the control button to select multiple ones or just one of them, and an optional description that you may add in case you want to have some explanation. Similarly to before, you create the annotation and wait for the annotator to update the entity. Annotations are displayed as a highlight piece of text with the color that is for the categories that you select, and the likeness is set depending on the certainty value. These annotations will be shown in an easily readable manner, saying who marked the piece of text and what the annotations mean. And as you can see, everything from the type of entity to the attributes and the annotations says that are unsaved. So you can discard, save, and later on edit those things, which can be either saved within the tab or using the top control. So the top control will allow you to save every single operations easily without having to search for each individual entity, and you can see the different changes. So you may hit the save button and save it. As we can see, it already updated, and more people could add more annotations, and you will see the web browser update. In case you have doubts regarding the colors, you have the legend here for each of the entities and the annotations. Lastly, you have some controls in case you want to hide some pieces of information, or you may leave it as it is. Clicking on the breadcrumb, you will get back to the files page so that you can choose another one and proceed with your analysis.